Open your browser. Type a website. Press enter. Within milliseconds, information arrives. Simple, effortless, invisible. Most people believe that is the internet. But what you see is only the surface. Beneath familiar websites lives another network, hidden, encrypted, distributed, invisible to search engines, invisible to ordinary users. Not because it is magical, but because it was engineered that way. Most discussions focus on illegal marketplaces, sensational headlines, cybercrime, anonymous hackers. But those stories hide something far more important: the architecture. Because behind every hidden service, there is hidden infrastructure. And infrastructure is where systems reveal their true purpose. The internet was never designed as a single destination. It was designed as a network, a resilient network, one capable of surviving disruption, routing around failure, finding alternative paths. That philosophy changed everything. Over time, different layers emerged. The surface web, where search engines operate. The deep web, where private databases remain inaccessible to public indexing. And hidden networks, designed to conceal both identity and location. Most people confuse these layers because they focus on visibility instead of architecture. The important distinction is not what information exists. The important distinction is how information moves. Every layer serves a different purpose. Every protocol solves a different problem. And every hidden system reveals another lesson about resilience. Identity has become one of the most valuable assets online. Every click, every purchase, every location, every conversation can become data. So another question emerged. What if communication could exist without revealing who sent it? That question produced an entirely different infrastructure, one where trust depends less on identity and more on mathematics. Encryption replaced recognition. Routing replaced exposure. Privacy became architecture, and architecture became leverage. Every anonymous network depends upon three interconnected systems. The first is encryption. Information is wrapped inside multiple layers of mathematical protection. The second is distributed routing. Instead of traveling directly, traffic moves through numerous independent relay points. No single relay understands the complete journey. The third is decentralization. No central machine controls the entire network. Responsibility is distributed. Authority is fragmented. Resilience increases. Each component appears ordinary. Together, they produce something extraordinary. A communication system where visibility decreases while survivability increases. The architecture is not optimized for speed. It is optimized for uncertainty, because uncertainty makes surveillance significantly more difficult. Traditional infrastructure usually has a center. Banks have headquarters, governments have capitals, corporations have executive offices. But distributed networks operate differently. Power is fragmented. Failure becomes localized. Removing one server rarely stops the network. Removing 10 often changes very little, because resilience is achieved through redundancy, not centralization. This philosophy has quietly influenced modern computing. Cloud platforms, blockchain networks, distributed storage, content delivery systems. Each borrows lessons from resilient network design. The internet did not merely create anonymous communication. It demonstrated how infrastructure survives under pressure by ensuring that no single point determines the fate of the entire system.
Every infrastructure creates a counter-infrastructure. As anonymity improves, detection evolves. As surveillance expands, encryption advances. Each innovation creates another response. The result is not a final victory, but continuous adaptation. This is not simply a technological competition. It is an architectural competition. Who builds the more resilient system? Who adapts faster? Who reduces fragility more effectively? The visible conflict appears political. The invisible competition is structural, and structures often outlast individual technologies.
Most people associate hidden networks with secrecy, but secrecy is only one outcome. The deeper lesson is resilience. Systems become durable when dependence decreases, when authority is distributed, when redundancy replaces concentration. The internet has always rewarded resilient architecture, not merely powerful architecture, because concentration creates efficiency, but distribution creates survival. And survival is often the foundation upon which future systems are built.
The dark web is often misunderstood because people begin with the destination. Systems thinkers begin with the infrastructure. The websites may change, the users may change, the applications may disappear, but the architectural principles remain: encryption, distribution, redundancy, resilience. Those principles now influence modern cloud computing, cybersecurity, financial networks, and increasingly, artificial intelligence infrastructure. Because the greatest innovations rarely stay where they begin. They spread, quietly, across entirely different industries. The infrastructure survives, long after the headlines disappear. Most people study what systems produce. Few study how systems survive. The visible internet delivers convenience. The hidden internet demonstrates resilience. And resilience is one of the most valuable forms of leverage any civilization can possess. Because technologies evolve, platforms rise and fall, companies appear and disappear, but architecture continues shaping the future long after individual products are forgotten. This is Nexera, decoding systems, architecting wealth.